Okay, everybody, we're working through the diploma prep material. This is the trig chapter, and I want to solve this equation right here. Okay, now this equation here has got a couple of problems with it. First of all, and I should say primarily here, the issue here is that I've got a cosine squared, sine squared, and a sine here. I really can't work with this if it's got multiple different trig functions there, unless I can separate them apart by factoring. But in this case, I can't. Okay, so one of these has got to go, and I would suggest it's the cosine that's got to go. The reason for that is if I get rid of the sine squared, I can convert that into an expression with cosine in it, but I'm still stuck with this sine over here. But if I get rid of the cosine squared by replacing it with 1 minus the sine squared of theta, okay, then I get plus sine squared of x, I should say, equals 4 sine x. Well, now everything is in terms of just one trig function, and that's the sine. So now I multiply that through, and I get 4 minus 4 sine squared of x plus the sine squared of x equals 4 sine of x. Now, perhaps maybe you're looking at this and you're like, there's so much going on with the trigonometry, I don't like that. So I'll tell you what, I don't know what x is, so I don't know what sine of x is, so let's just make sine of x x. And so this becomes 4 minus 4x squared plus x squared equals 4x. And I can work with that far easier here. Okay, I can see right now that I've got negative 4x squared plus x squared will be negative 3x squared. I don't want it to be negative, so I'm going to bring it to the other side. So that'll be positive 3x squared. There's already a 4x there, and I'll bring this positive 4 over to get minus 4 over here. So now this is just a quadratic that I can work with quite easily, okay? Because we can factor that. We'll get 3x and x, and what's this got to be here? This got to be plus 2 and minus 2. So now I'm getting two scenarios here where one where x is 2/3, and the other where x is negative 2. So now I've dealt with the algebra or the polynomial part of this problem. Now I got to go one step deeper. Oh, that looks like a big old 8 there. I don't want that. Hold on. 0. Now I'm going to go one step deeper and take a look at the trigonometry, because this tells me one of two things. Either the sine of x is going to equal 2/3, okay, or the sine of x is going to equal negative 2. Now, I got to consider the domain. So this is one complete circle positively. And so I'm looking where sine is positive 2/3. That's going to be quadrant 1 and quadrant 2. And to figure out what the angles are, I got to figure out the reference angle. Now, it's very tempting at this point to sit and look at this and go, oh my gosh, I don't know, 2/3. It's not a unit circle angle. How am I supposed to figure this out? But it's been so long with you guys doing it, working on it like that, that you sometimes forget that, oh, I just plug that into my calculator and I get 42 degrees. Okay? If you get stuck, just use your calculator. And then in the in the first quadrant, that's going to be 42 degrees. In the second quadrant, it'll be 138 degrees. Now, I think this is a really good question here because I've done all that. I figured out my two angles. It's great. And when I move over here and take a look at this next factor here, sine of x equal to negative 2, well, this kind of forces me to think about this a little bit and think, well, wait a minute. I know what the graph of sine of x looks like. Its range is negative 1 out to 1. It can't equal negative 2. There's going to be no solution to this. And in fact, even if you tried to on your calculator, it would give you an error. So the only answers that make any sense here in the domain that are given is 42 and 138.